So in the last video, we saw how to use the concat function. Now in this video, let's understand the minus function. Before that, let's see how the minus operator works on arrays and JSON objects. Like I have an array of numbers and I want to remove a certain number. So I'll use a minus operator and give the number. So it removes all the occurrences of that number in that particular array. So now we have left with 1, 2, 3 and 4. 0 is removed. In the same way, if I want to remove an element from an array which has multiple JSON objects, what I can do is I can just mention the key value pair hello and world, and it removed the hello world element. We only have hi world and hi there. Now if I have only a JSON object, remember this is not an array, it's only a JSON object, and I want to remove a particular key, so I can use the minus operator and just mention the key hi world. So what if I have another key value pair with the same key name? Will it remove that as well? Yeah, it removes that as well. But if I give hello, so it removes all the keys with name hello. Like when we used hi, it removed all the keys with name hi, irrespective of the value associated with the key. But what if I want to remove a specific key value pair? Will that be possible with the minus operator? Let's try that. I want to remove hello world. So it's not working, right? It's saying unable to call minus, expecting key but got hello world string. So it expects only a key every time. So how can we do that? So that's when you use a minus function, and the minus function removes the key value pair. What if I want to remove hi and there? So it removed hi world, right? If when we give hi world, it removed hi world, and we have only hello world and hi there left. If I want to remove specific hi there, it removes hi there. So the minus function helps you to remove a specific key value pair from a JSON object. So what are the inputs? JSON object and JSON object. So one of the input is object and object. That is the combination for a minus function. Now let's try the same with an array. So let's see if this combination works. It doesn't work, right? Means array as an input and the value that needs to be removed as an object doesn't work with minus function. Let's see what is the error. It is saying unable to call minus with array and string, right? So we need to add it as an array. So it works now. So it is removing hello world, and we only have hi world and hi there. So another input that the minus function supports is array and another array, and that array can have anything. Now if I want to remove multiple key value pair, it's simple, just add those key value pair. For example, I want to remove hi and there, just add it, and it removed hi there as well. So in this case the minus won't work when you want to remove multiple key value pair. Always use the minus function and give the input as an array and the values to be removed also as an array. Again, for the numerical array, can we use the minus function right away? No, it again needs array, right? So we pass the array. So since it is an array, you can remove multiple values like 4, like 2, and all the values get removed. And remember, any duplicate values, all of those value will be removed, as opposed to removing only the first value. It removes all the zeros when I mentioned 0. So these are the different combination with which you can use the minus function. Now let's understand the zip function. Suppose I have two arrays. One is international standard book number and the other array has the name of books, and both are correlated. Like if the first element is 1875, so 1875 corresponds to the book Kafka on the Shore, and similarly the second array correlates to the second array of books array. Element corresponds to the second element of books array, right? So in case if you have such situation and you want to create a single array like 1875 and Kafka on the Shore in one array, 9142 and Java for Dummies in one array, you can use the zip function. So let's see that function in action. What I'll do, I'll just write zip, and then what you have to do is at the left hand side give ISBN, and at the right hand side let's give books. It doesn't matter what you give on left and right, ultimately it's the same output that you're gonna get. So we have the segregated array, right? Like 1875 Kafka on the Shore, 9142 Java for Dummies, and 8742 Cloud Native Java. But there was one extra element in ISBN, that was 8471, but there was no corresponding value for the element 8471 in the array books. So the zip function eliminates that value, so you won't get the value in this, right? And there is the opposite of this function is unzip function. So zip function takes two arguments, both have to be array, and that's the reason we could apply chaining on it. And unzip function will unzip all the values. So if you zip and unzip two particular array, there might be a chance that you might end up losing the values, because in this case if we unzip, we are not going to have 8471, right? Because it has only 3 values as of now. So let's try unzip and let's see the output. So we have two segregated arrays. So whenever you encounter such a situation wherein you have two arrays and those are correlated, share some relationship between each other, provided that the indexes are same, you can go with the zip and the unzip function. Now when we do a zip, we have this type of structure, right? And it's array inside of an array, right? Because it returns a zip and all the elements are being put into an array. You can use a flatten function when there is an array inside an array and everything comes out, like flatten, and see everything came out of an array, and there is only one array at the root level. So whenever you have array nested, so you can use a zip. So if the flatten works only on those array which has array at the first nesting level. For example, here it was only at the first level, right? After the root array there were 3 arrays at the root level, right? After the root level. But in case if there was an array inside an array, that would be untouched, nothing would happen to that. So that's a catch over here, that if you're applying flatten will be applicable only on the arrays which are first after the root array. If there is a deep nesting of array, that's not gonna work. Now let's understand how can we iterate through an array, and that can be done using the function map. So let's write map, and first let's see what the map function is, what is the structure of a map function. So as you can see, the map function has 2 arguments, right? One is the stream capable annotated array, so that is items, which is of type array, okay, and the next argument is a mapper, which is a function that is a lambda, and that function takes in 2 arguments, item and index. So the map function takes in 2 arguments, one is an array, second one is a mapper, which is nothing but a lambda or a function you may say, and that function takes in another 2 arguments that are item and index. Item means the object and index means the index at which the position of the elements in array, and it returns an array. So that is the structure of a map function. It returns array, takes in array as the first argument, takes in a lambda or a function as the second argument, and since that function is a second argument is a function, so function may take or may not take an input. So but this function requires two input. One is an object and other is an index which is of type number, and since this item is an object, it is of type t. Okay, and it returns an array of type r. So this is the return type. R is the return type array. So now let's go back to the Dataweave script and let's see the map function in action. Let's open up a preview and let the preview come. So I'm applying a map function to the books array. So again, this is the chaining way that we went. You can also go as map and then books and then $. That can also work, but now let's go with the chaining approach. Let's books map and okay. So whenever you use a map function, the second argument, if you do not specify any lambda and you do not give it any input, it gives you two implicit names. One is the $, and the other is single $, this way, right? So the single $, as visible, is the first argument of the function, right? I mean to say this, if we go back to this core.dwl, so this is the second argument of the map function, and the single $, is the first argument of the second argument of the map function. So this is implicit name which DW gives you by default is $, and index is specified by $. So if we go back over here and hit on preview, I'm getting all the values, right? And the return, since the return type was array, the map returned an array of all the values. Now if I want to apply any functions again to this, since the mapper argument takes in function, we can also pass functions like upper and then $. So everything becomes in uppercase, right? Now if you want to like concatenate some string with it, even that can be done. Use the ++ function and add s, so it is adding s to the values. Suppose you want to modify the indexes, like you just want indexes number and you just want to add 1 to it, so it should add 1 to it, right? The Kafka on the Shores index, if I show you the index, it's 0, so if I add 1, it becomes 1, 2 and 3. In the similar way we can do with ISBN, and if I use the $, it increments the ISBN number by 1. So this is how we can use this implicit names $, and $. Now let's try some other ways of using this $. I want to modify this array. I want to just create a new array out of the existing books array. So I'll use books, and then what I'll do is I'll create an array which has JSON object. So when I gave this 2 curly braces, it gave me 3 different objects, because the books variable has 3 elements, and since the map is running on books element, it will obviously give me an array of size 3. Now Suppose I want to do some modification, like I want to give an ID, and ID should be the index. So what I can do is ID dollar dollar. So I'm getting ID and the index of the array. Now if I want to specify name, and that can be done by the dollar. So I'm getting name and the value. Now what if you want 0:, this name? So you can easily do that. Just use dollar dollar colon dollar. Now remember, whenever any value is on the left hand side which is dynamic, ensure that you enclose it in round braces, so that will evaluate the value. Like dollar dollar, it doesn't understand. If you see the error message, invalid input, is saying expected namespace or attribute, so that is the error. So if you enclose it in round braces, it will evaluate the value, okay, and then you have the value like 0, 1 and 2. So that is how you can use this map and create a new object out of it. Or if you just want to right away use the dollar and just do small manipulation, you can directly use dollar and apply functions on it, right? It's okay. It applies on double P. Yeah, so we have in dollar. So if you want to create objects out of it, just create an 2 curly braces and enter whatever you want and do the manipulations accordingly. Now what if I want 1875 linked to Kafka on the Shore, 9142 linked with Java for Dummies? How can I do that? Since we have already seen the map, we have already expanded the map and we are trying to create objects, we can easily do with the help of the dollar dollar and the dollar names. So what we have to do is just use the ISBN, all right, and then the array, use the dynamic selector to select the values from that particular array. So we want the index, right, and we get the index using the dollar dollar name, right, and we want the associated name from the books array, so we can get it using dollar name. Now again, we want to evaluate the value of dollar, right, so we need to put this dollar into round braces, so it will evaluate the value like 0, 1, 2, and then again this part has to be evaluated. The value of this part has to be evaluated, because if it is as it is, then it thinks that this is a string and the string is not specified properly, so it's complaining about that. So if I put it in round braces, the value gets evaluated, and if you can see, we get the value 1875 corresponds to Kafka on Shore, 9142 corresponds to Java for Dummies. In this way you can again use this dollar dollar and dollar to correlate two different arrays and form their value as key value pairs. So this could not be done using the zip function as we saw previously. It was just creating arrays out of it and giving elements, right? If I show you again, ISBN zip books, we didn't get key value pair, right? It was just two independent elements. So if you want to correlate them using key value pair, go with the map function, and then you get this type of construct. Now sometimes it may happen that you are uncomfortable with dollar dollar and dollar symbol, that you don't understand, or if there is some new developer, he might not understand it at the first glance, right? So what we can do is, these are implicit names, right? If you do not specify, only then they come into action and you can use them. But if you want to specify your own names, you can very well do that, because there is a provision. Like I said in previously, we saw that map function takes in two arguments. One is the array and other one is the lambda. So we have given the lambda and it takes two arguments. So here the dollar and dollar are the two default arguments or implicit arguments provided. Now you can use your own custom arguments. Just use a round bracket, and remember the first one would be the object, so it will hold the actual value in the array, and the second one will be the index. So the first one by default is dollar and the second one is dollar. So we just gonna replace those. Like I'll say object, so this is dollar, and index is double dollar. Then use an arrow and give your implementation. So again we are back with the same thing, right? This giving this part, this lambda, is same as just saying if you remove this part, it becomes the same thing, right? There's no error, nothing. It's the same thing, just that we are giving our custom names to it, right? So remember, if you do not provide this, no issues. Dollar and dollar will be the implicit names. Now if I try to do the same thing like ISBN, then the index, in this case I'll be using index, not dollar because those are removed, and then I'll place the object. There's an error because I'm not evaluating this value. If I evaluate, I get the value. So now do you think dollar will work? Let's try with dollar. See, it doesn't work. What is the error? Unable to resolve the reference of dollar, because we have replaced dollar with object, sorry, dollar with index and dollar with object. So we have to use the custom names that we have given. So remember, if you do not specify any default names, dollar and dollar will be the default names for the map function. Now what if I want to iterate over an object? We learned how to iterate over an array. There might be chances you might wanna iterate over an object. So that can be done using the MapObject function. So let's try the MapObject function. For that I have a book details, which is a JSON object and not an array. So what I'll do is book details and then call the MapObject function in the chaining fashion. And now the MapObject function is same as the map function. The structure is same, only thing is the second argument and the return type changes, and the first argument is also slightly different. So the map object takes in a JSON object, it does not take an array. Okay, the second argument is again a lambda, but the lambda is slightly different. That particular lambda will take in 3 inputs or 3 arguments, and the first argument would be the key, the second would be the value, and third would be the index. Let's just check that out. Let's control and click map object. Okay, so or maybe I made a mistake. The first is value. We'll come to this, but let's first observe the anatomy of this map object function. So map object function, it takes a stream capable object. It represents key value pairs k and v. Then the second argument is a mapper, same as the map function. The mapper takes in 3 parameters: value v, key k, and index, which is of type number, and this returns an object. The whole function is returning an object. right? So this is the structure of the map object function, pretty much similar to the map function, just that the return types, the first argument and the arguments of the mapper argument have changed. So let's go back to the script. Okay, now remember, even map object gives you implicit names like dollar, double dollar, but as opposed to map, it will give you a third name which is triple dollar, because the second argument of map object was taking three different arguments, right? First one was the value, key, and the index, that is number. So let's try that out. So do you think directly giving dollar will work? No. Why? Because it returns an object, not an array. So in case if you run you mention just simple dollar in front of a map function, that would work because that returns an array. But in case of object, it has to be a key value pair. So if you just return dollar, it won't be a key value pair, right? It will be a single value. So that's the reason it doesn't work right away. You should always use open with curly braces, and again inside if you add dollar, that just won't work because it has to be a key value pair. So if I say dollar colon dollar dollar, this is going to work. So there is an error, like, okay, so this is not working because I need to evaluate this value. Now it's working, right? So dollar, as you can see, stands for the value, whereas dollar dollar stands for the key. Then what does that triple dollar stands for? It stands for the index. So the index of ISBN is 0, for name is 1, and for the author it's 2. So remember, we have three implicit names: dollar, double dollar, triple dollar. Dollar means value, double dollar means key, and triple dollar means the index. Now what if I don't want this dollar dollar dollar? This makes it quite confusing, right? So again, what you can do is you can create your own names. Like, what I can say value, then key, then index, and then give the lambda, and yeah, we have it. So let's see what is value colon, let's say key colon value. So it's taking as straightforward string. So it made key as key, right? We are getting just key. So that's the reason you need the round braces to evaluate this. Now we are getting the proper keys, right? And if I add an index over here, I get the index. Now you can apply all sorts of function you want to apply, like upper of what value, yeah. So everything became in an uppercase. So you can even do the same operation on the key as well. Like, I want to make the key as upper, so I can do the same, just that, and close it in round braces so it gets evaluated. So see, it became in uppercase. All the key and value, both of them are in uppercase. Now what if I want to add some values in between? Like, I want to add a publisher after the name key value pair. Is that possible? Yes, it is possible. Let's see how we can do that. So what we'll do is we'll just remove this first of all, and we have a blank object. Now let's add an if and else condition and find out this particular key. If we get the key, we'll add the new key value pair to that key value pair, right? So let's ensure that you enclose the if else condition into a round bracket so that it gets evaluated, otherwise it will give error. Now what I'll do is I'll place an if and then else type of construct, and in this if what I'll do is key equal to let's evaluate this key, key equal to what was the key name below which we wanted, its name, right? So let's give it as name, and then what we can do is just open curly brace and close it, then we'll put the key as it is, key and the value. So fine, then in the else statement we just want the key and value as it is, we don't want to make any modifications to it. So key and value, so we are getting the values, right? Now I want to add that particular key to it, key value to it. So below this, since I'm finding out name and I'm entering this if block, I want to add it, like I'll do this comma, then I'll add publisher and then RHUK. Perfect, but the value didn't appear, right? What's the problem over here? Let's try to understand that. What if I make this key as string? Will it work? Yeah, it did work. It did come into the if block and then it added the publisher. You can add multiple values to it, but now why did we have to make it as a string? Was it not a string when it got evaluated under the round braces? No, it wasn't. So what was its type? Let's try to find out what was the type. Let's add a new key, and what I'll do is type of and then give key to it. So notice that the type is key. So remember, there is also a type called as key. So we made the type key into a string and then it was able to compare with name. So here we have casted key to a string. Now you can add as many key value pairs as you want, and that would give you the desired JSON structure. Now there's yet another way to do this. Like if you don't want to enter it here, you can use the concat function to do this as well. Let's just cut this part and we can add after this braces, right? And what did we see in the concat function? If we add an object with an object, it will merge both the object, right? So this should merge both the object. What I'll do is add plus plus, then give an object and then add this value. See, we get the same output. So we can either put the values inside the single object or we can use the concat function. Now you might be thinking where this sort of structuring of JSON would be useful. Well, in case you want to create a CSV out of an object, out of a JSON object, in that case in CSV the sequencing is very important. In case if you do not have headers, you have headers turned off, the sequence is very much important in case of CSV. So in such scenarios you might need to add a particular key value pair at a specified position, and in such cases you can use this technique to add the key value pair at a particular position. So let me just quickly demonstrate this, like when I mentioned the case of CSV. So let's change the output type as CSV and let's see if that works. See, so what we have, the sequences like ISBN 1875, name as Kafka on the Shore, and publisher as RHUK, key as key, and the author, right? So in case if this is a CSV, the sequence does matter, right? If tomorrow I remove the header, if I mention as header equals false, I don't have the header. So now The sequence is very much important over here because the first one is considered as ISBN, second one is name, third one is publisher, fourth is the key, and the fifth one is the author name. So that's the reason you would need to implement such use cases wherein the sequence would be much more important. Now what if this is enclosed into an array, like book details is an array? Will the map object function work? No. Let's see what the error is. It says expecting type kv but got array. So it's expecting something as key value pairs, right? But it is getting an array. So what we have to do now in this case, now book details is no more a JSON object having key value pair. Instead, it's an array. So we need to use the map function. And again, in map function, you have to provide some names like, or you can, let's provide object index and then give the lambda and it runs on an object. There's some mistake over here. Let's check that. Issue found expected namespace or attribute. I think this object index. Yeah, so it's working as expected, right? We created map, then object and index, and the map object is running on the object. So you can also enclose this in round braces as opposed to the curly braces, and again it will work perfectly fine. So this is how you can use the map and map object function to manipulate arrays and the JSON objects. And we also saw how to use the zip and unzip function and the minus function. I hope you found this video useful. Thanks for watching.